This is Geometry, Lesson 1-7, Midpoint and Distance in the Coordinate Plane. Our objectives for today are to find the midpoint of a segment and to find the distance between 2 points in the coordinate plane. So the first one we're going to talk about, ooh, those boxes are messy, is that on a number line, the midpoint formula is the coordinate of the midpoint is the average or the mean of the coordinates of the endpoints. So basically what you're going to do if you're working on a number line is you're going to take the coordinates of the two endpoints A and B, add them up and divide by 2. That's it. It's pretty straightforward on a number line. It's a little bit different in the coordinate plane. In the coordinate plane, you need to average the x values and you actually need to average the y values of those coordinates. And so you can see you have the x values of coordinate A and the x value coordinate. So you can see the x value of the A coordinate, x value of the B coordinate, add them up and divide by 2. You do the same thing with the y values, the y value of the A coordinate and the y value of the B coordinate, add them up and divide by 2, and you'll end up with that midpoint right there. So let's figure that out. Problem 1, finding the midpoint. Segment AB has the endpoints at -4 and 9. What is the coordinate of its midpoint? This is on a number line, as you can see, so we're just going to average the two endpoints. A is at -4 and B is at 9. We're going to go -4 plus 9. That's going to give us a total of 5. We then take that 5, divide it by 2. We get the midpoint to be at 2.5. We do the same thing in the coordinate plane, but with the x values and the y values. So EF has endpoints E at 7, 5 and F at 2, -4. What are the coordinates of its midpoint M? So we're going to add the x values, 7 and 2. 7 plus 2 is 9. We're going to then take that 9 and divide it by 2 to get an x value of 4.5. So we have the beginning of that, 4.5 for our coordinate. We do the same thing with the y values, 5 plus -4. 5 plus -4 is 1. 1 divided by 2 is 0.5. We have 4.5, 0.5. If you want to graph that, you can see that here it's going to be 1, 2, 3, 4.5, 0.5. The midpoint will be about right there. This is the basic way of setting up and finding the midpoints. Sometimes we are given one endpoint and the other midpoint. Our job is to then find the other endpoint. So we have to kind of work backwards a little bit. We can use the midpoint formulas that we have up above to do these, but I actually prefer a different method. I call it the stacking method. And so what we do is we say, okay, the midpoint of segment CD is -2, 1. One endpoint is -5, 7. What are the coordinates of the other endpoint D? And so we take that endpoint, -5, 7. We put the endpoint on top, so -5, 7. We take the midpoint, -2, 1, and we put it below. And then the other endpoint's going to be below that. And so what I do is the distances between the endpoints and the midpoints should be the same. So I look to get from -5 to -2, I add 3. So to get from the midpoint to the other endpoint, I'm going to do the exact same thing. I'm going to add 3. So I go -2 plus 3, that gives me a +1. And I do the same thing with the y values. 7 to 1 is subtract 6. So I subtract 6 from 1, and I end up at -5. My other endpoint then is going to be at 1, -5. We can graph that, and hey, that's exactly where it should be. The one key on this, so if you choose to do the stacking method, is that you need to make sure that this is an endpoint, the top one in your stack, and that the middle one is actually your midpoint. Kids mix up that order all the time. So I want you guys to pause the video and try this next one on your own. You can check your work with mine. The one thing you just need to be careful is that you put -3, -5 on the top of that stack and 4, -9, 1 in the middle. I noticed right away they said the midpoint, and they're talking about 4, -9, so I put an M in front of it to refer to it as the midpoint to remind me that the midpoint should go in the middle of that stack. You should have that endpoint then be at 11, -13. Okay. The next formula is a very useful formula. It's the distance formula. The distance formula says the distance between any 2 points in the coordinate plane is that right there, the square root of the difference in the x's squared plus the difference in the y squared. Really, the distance formula is based on the Pythagorean theorem, and you can actually use the Pythagorean theorem to help you if you already know that. So basically what we do when we're doing the distance formula is we have to plug in these coordinates into the formula up above. The directions say to round your answer to the nearest tenth, so when we get done, we're going to have to make sure we round stuff. So the distance formula, I want you guys to copy it down with me. It's d equals the square root of the difference in the x's, so it's x2 minus x1, squared plus the difference in the y squared, y2 minus y1 squared. And so you got to kind of pick and choose with your order pairs, which one's going to be the first one, which is going to be the second one. I'm going to pick U to be my first order pair and V to be my second order pair. Now remember that ordered pairs go x, y. So the x values of the first one's the -7 and the 4. And so it says x2, which means I'm going to take the x value from the second ordered pair. So the x value from V is 4, and I'm going to plug that in right now. So I have 4 minus the x1 value, x value from the first order pair, -7, squared, plus y2, y value from the second order pair, -3, minus y1, the y value from the first order pair, 5, all squared. And now it just comes down to simplifying. I would not recommend that you type this into your calculator. I would actually recommend that you start to do some of this by hand, because a lot of people don't type things into their calculator correctly. So let's do 4 minus a -7. That really becomes 4 plus 7. That's going to give us 11 squared, plus -3 minus 5. That's a -8 squared. And really that 11's in parentheses as well. 11 squared is 121. -8 squared is the same as 8 squared. That's 64. Add them up. We get the square root of 185. Now I would get out my calculator and type that in. If you type that in, you're going to get something about 13.601, which is about 13.6 units. The reason I rounded is it says to the nearest tenth in the directions. What I'd like you to do now is try this next distance formula problem on your own. Pause the video and then check your work with mine. All right, check your work with mine. You could have done the first step differently from me. If you did the first step different, where you should end up being the same is right here in step 3, regardless of how you set it up. If your step 3 is different from mine, that means the original setup did not work and you need to go relook at how you plugged stuff into the distance formula. But if you end up with the square root of 25 plus 225, then your setup worked. You should end up with the distance being about 15.8 units. We've got one problem left to go. This one's an application problem. It says finding distance. On a zipline course, you are harnessed to a cable that travels through the treetops. You can start at platform A and zip to each other platform. How far do you travel from platform B to platform C? And tell you that each grid represents 5 meters. So let's start by finding B and C. It looks like B is down here and C is up there. So what we want to start off with is actually finding the coordinates for both B and C. So B, let's take a look at that. Here is your origin. It goes back -30 and it goes down -20. We want to do the same thing for C, find its coordinates. It's going to go back -15 and up 10. Now all we do is we just plug those into our distance formula. So I actually want you guys to practice doing that on your own. So pause the video here and actually practice plugging that in and check your work with mine when you're done. All right, check your work with mine. You should end up with, when you plug it in, you can see the first step. Second step, evaluate inside those parentheses. Third step, evaluate those exponents. Combine your two terms, and you should get it to be about 33.5 meters is the distance from B to C. And that is the end of lesson 1.7. Our objectives were to find the midpoint. Remember, a midpoint of a segment in the coordinate plane and on a number line, and to find the distance between any 2 points in the coordinate plane.